I used AI to generate all of the textures you see in this TF2 map called Gorge. More specifically, I replaced every single texture assigned to all brushes and displacements with AI-generated ones. Now, just a disclaimer, I didn't replace everything. For example, I didn't touch the models because they use baked textures which are very precise and beyond the scope of the tools I used. I have seen some ways online to do this in Blender, but for this project, I decided not to go down that rabbit hole. I also left the overlays alone because AI can't generate text properly, so these particular ones you see here would be impossible to generate, and I didn't want to pick and choose which ones to do, so I ended up just leaving them all in. The purpose of this project was to see how well AI could generate textures for TF2, and all around, even though some textures look super goofy, I think it did a pretty decent job, especially considering that I did this within 2 days and didn't have to pay for any credits, which plague many of the AI tools out there. But enough rambling, let me explain how I managed to do this. The first step was to figure out what map I wanted to transform, and since 90% of my videos have been about either Two Fort or Dust Bowl, I decided to change things up and go with Gorge. It's a fairly small map with a simple texture palette, so it was the perfect choice. Next, I acquired the map's VMF file from the TF2 repository, because even though I was only changing the textures and not the map, I would still need to tinker around within the Hammer editor, starting off by extracting the texture data. Because before generating all of the texture files, I first needed to extract the existing textures VMT files, which are basically sets of parameters that tell the game things like where the texture is located, what texture maps to assign, and other shader related things. So for example, this texture here has the path nature/dirtground009, which tells us that it's within TF2's materials directory underneath the nature subfolder. And using a program called GCFscape, I can access its VMT file by opening the TF2 MISC directory VPK file located within the TF folder. I need the VMT file because what I was trying to do was essentially like making a Minecraft resource pack, where all you do is change the textures while leaving the directory alone. Doing this over creating a brand new texture name and VMT file speeds things up tremendously because all I have to do is create the new texture and the VMT file immediately shows me the results from within the Hammer editor. So in this example, I extracted the dirtground009 VMT file to a copy of the same directory I created within the TF custom folder, which is where I'd be putting all of the generated content. In this case, I also extracted the VTF, or texture file, and threw it into Photoshop. Not to manipulate, but to get the right dimensions so that I could automatically resize the AI-generated content, which is the next step. I had to figure out what AI tool to use. The most popular ones are Dolly and Midjourney, but they both require credits, and I didn't want to pay for anything. So instead, I used Bing Chat, which is free and actually incorporates Dolly in its image generation. So for this simple dirt ground texture, I just typed in the prompt, generate a dirt ground texture that is seamless, and after about 15 seconds, Bing gave me 4 different textures to choose from. In this case, they all look really good, but in the cases where I got something that I didn't want, I just told Bing to generate more with additional parameters. But these freshly generated dirt textures aren't sufficient. To show why, let's jump over to Photoshop. Here I've imported and tiled all 4 of those dirt textures you just saw Bing generate. And what you see is that they aren't actually seamless, meaning you can see the borders around each tile. This is because even though I told Bing to make the texture seamless, it just didn't, so I'd have to fix that later. The first thing to do was a little bit of Photoshop manipulation. Take this dirt texture here for example. This top part of the texture is brighter than everything else, and there's a watermark in the corner that I need to remove. So taking care of the latter first, I can use Photoshop's new AI remove tool to get rid of it quickly just like that. For the former, I can use the burn tool to darken the brighter part of the image until it roughly matches the same brightness as the rest. Now we have a watermark-free dirt texture with consistent lighting, but we're still not done yet because the texture isn't seamless. To get around this problem, I used a program called Materialize, which is a fantastic tool for manipulating textures and creating texture maps. Walking through the process for this dirt texture, the first thing I do is select this open button under the diffuse map box and select our refined dirt texture. Next, I create a height map so that I can click on this tile maps button. By increasing the texture tiling and messing around with the edge fall off and overlap, I'm able to create a pretty good seamless dirt texture. But in some cases, I preferred using the technique splat option for more randomness. In this case though, the default texture overlap settings work great. So now I hit Set Maps, which updates our base texture, and I can export it by pressing the Save Project button. Now in order for the source engine to read the texture, it needs to be formatted as a VTF. To do this, I use a program called VTFEdit, import the PNG from Materialize using the default settings, and then save it in the same directory as the VMT file. And now if I tab back over to Hammer, we see our new dirt texture already applied. When generating the textures for Gorge, I took an extra step and used VTFEdit to generate normal maps for them as well to give more depth, which also required me to add this parameter within the VMT file, which tells TF2 to apply the normal map. So what I've just gone through was the best case scenario for these generated textures. Some of them took many generations and Photoshop manipulation to actually work, like this concrete wall texture over here. While Bing was able to generate the underlying concrete texture, it could not generate these lines and dots, and I didn't want this entire building to look like this, so I added them in myself. Some other things that were incredibly difficult to generate were the transparent textures, which included the glass windows and metal grates. Because Bing can't generate transparency, I told it to generate over a white background so that I could use Photoshop to add the transparency for myself, which for some of the textures required some workarounds. They're still not perfect, and I wouldn't in any case try to pass them off as valid textures for general use in mapping, but for this project and its constraints, I'm happy with the output. Another niche thing I had to do was create the 2D skybox, which was much tougher than I initially expected. In the source engine, a skybox is made up of 6 separate textures aligned in the formation of a cube, which means you have to create 6 VMT and VTF files that all connect to form a seamless environment in-game. But before creating these 6 different textures, I needed an actual scene. Gorge's skybox, whose file name is SkyTrainYard01, has a blue sky, distant mountains, and some snow. This I could replicate, so I went into Photoshop and used Generate a Fill to create a similar scene. And the result was perfect. At this point, it looked like everything was going to be easy. I just split the image into 6 squares using the slice tool, and voila! But actually, this wouldn't even come close to working. Instead, I had to use a program called Qbit, which takes a source image and automatically separates it into 6 textures. The problem with the one I just generated in Photoshop is that there's a clear seam between the left and right side of the image, which is easier to see when I cut and rearrange them like this. So I just used Generate a Fill once more to make it seamless, then put them back in their original positions. From here, I imported the scene into Qbit, which generated the 6 skybox textures, and after turning them into VTF files and setting up the VMTs, it came out like this, which I'm very happy with. The top part of the skybox is a little stretched because my generated texture isn't in true panoramic form, so the top and bottom is a little distorted. But it's not like you'll ever see the bottom, and the top isn't that noticeable unless you stare straight up into the sky. Before finishing, I want to quickly go over the exterior and interior of the B building. On the outside, if I click on one of these brick textures in face edit mode, you'll notice that the texture scale reads 0.2. If I click on this tile texture inside, it says 0.1225. For many of the textures, I had to manipulate the scale and alignment because most of what Bing generated did not match the scale and alignment of the default textures. In fact, going back to the tiles, I actually split them from this concrete texture above with this red line because generating them together would have been impossible. And speaking of that red line, I added it in Photoshop when recreating the D variant of this wall texture. The whole process was very tedious, especially when working with this concrete texture indoors because I had to realign literally every single face, which probably took me more time than anything else in this project. But several hours later, the map was finally complete, and I compiled it using a program called CompilePal. You can find a link to the finished map in the description, and if you'd like to play on it, I'll be hosting a playtest event sometime in the future, so be sure to join my Discord server using the other link in the description so that you can participate in that and other events later down the road. Thank you for watching. This is LED switching off.